Okay, so hello. We're going to discuss angles and vectors. So first for angles, I'm gonna discuss how to measure them, what are the different measurements that you could incorporate to a specific angle. Okay, so let's start. Um, let's say this is vector A, angle A. Okay. So if this is angle A, let's say from this side going to that side, the measurement is 40 degrees. Okay, so this is angle A. Therefore, angle A is equivalent to 40 degrees. But you can also express that angle in a different numerical value. Okay, so when we measure angles from the positive x-axis, okay, so from the positive x-axis counterclockwise, that's a positive angle measurement. But you can also say that the measurement of this angle is, let's take it from the positive x-axis on a clockwise direction. Okay, since 1 revolution is equal to 360 degrees, therefore angle A is also equal to 360 minus 40, that's 320 degrees. But if you're going to measure an angle on that direction, you need to indicate a negative sign, okay, stating that you measured that angle clockwise. All right. You can also name this angle by adding one more revolution. Okay, so let's say we're going to take the positive direction. Okay, so let's say from this point, okay, and then you're going to add one revolution and an extra 40 degrees. Okay, so therefore angle A could also be equal to 360 plus 40 degrees is equal to 400 degrees. Okay, so therefore there are different measurements that we could express for a single angle. Okay, next let's talk about Cartesian plane. So Cartesian plane, alright, here is our Cartesian plane. Okay, this is our positive x-axis, this is our positive y-axis. Okay, this is the origin. Okay, now I want to incorporate the discussion of Cartesian plane with the rectangular form and polar form. Okay, so let's say we have a point, okay, somewhere around here. Okay, so here is our point A. If you're going to draw a line from point A to the origin, okay, we actually have created an angle. Okay, so this vector from origin to the point A has a direction, okay, and that direction is measured by an angle. Okay, let's say this is 50 degrees. Okay, let's say that is 50 degrees. Now, if you're going to express this one, I have to indicate the measurement of the vector. Let's say the vector measures 3 units. Okay, 3 units. Okay, if we're going to express this vector in rectangular form, before rectangular, let's proceed with polar form first. Polar form. Polar form is expressed in this form, r and then the angle theta, therefore the magnitude and the direction. Okay, so for the polar form, the measurement of the vector is 3 units. Okay, so therefore for the polar form we have 3 units, okay, with an angle of 50 degrees. Okay, so this 3 angle 50 corresponds to this vector A. Now, we could also express that 3 units at a 50 degrees direction with an angle of 50 degrees in rectangular form. So how are we going to do it? Now, if you're going to take a look at our vector, we can actually formulate a triangle by drawing a line, a vertical line from point A. Okay, so this vertical line corresponds to the y coordinate of the vector A. Okay, and this line from origin to that one, this horizontal line, is actually our x coordinate. Okay, and rectangular form is expressed as xi hat plus y j hat. Actually, it is properly expressed as ai hat plus bj hat. Okay, wherein a is the measurement of x coordinate and b is the measurement of that vertical line. Right. Now, since we already have the triangle, let me draw it for you first. We have formulated a right triangle here. And, okay, so that doesn't look like a right triangle. Anyway, let's say this is a right triangle. Okay, and this is 3 units we said, and this is 50 degrees. Now, we have to get the measurement of these sides. Okay, so by applying Pythagorean theorem or SOHCAHTOA. Okay, since we already have the hypotenuse side, okay, by the way, so means sine theta is equivalent to opposite side over hypotenuse side. Ka means cosine of an angle is equal to adjacent side over hypotenuse side. And TOA means tangent theta is equivalent to opposite side over adjacent side. So we're going to apply this. Okay, since we already have the value of the hypotenuse side, therefore we can solve either A or B. Okay, so let's analyze it. Okay, since if we're going to analyze side A, okay, side A is the adjacent side of the 50-degree angle. It is the adjacent side of the 50-degree angle. Okay, so we say that A is the adjacent side. Now we have the adjacent, we are going to solve for the adjacent side, and we already have the hypotenuse side and we have the angle theta. Therefore, we can make use of cosine. Okay, cosine 50 degrees, that's the measurement of the angle, is equivalent to adjacent side, that's A, over 3 units as the hypotenuse. Okay, we cross multiply it, we have side A is equivalent to 3 cosine 50 degrees. Okay. Okay, and that's 1.9283 units. Okay. Next, for angle B, for side B, you can either use sine, tangent, or the Pythagorean theorem. Okay. So Pythagorean theorem states that a squared plus b squared is equal to c squared, or the summation of the square of the two other side is equivalent to the square of the longest side. Again, the square of the longest side is equivalent to the summation of the square of the two other sides. Okay, now if we're going to solve for side B, therefore it's gonna be c squared minus a squared. Okay, and that's 3 squared minus 1.9283 squared. Okay, so we have 9 minus square of the answer, so giving us a value for B as 2.2981 units. Okay, so we already have the values for the adjacent and the opposite side, therefore we can get the rectangular form of that vector. Okay, so the rectangular form would be 1.9283 I hat plus 2.2981 j hat. Okay. Okay. So these two, they only they correspond to the same vector, but they have they are in a different form, but they're still talking about same vector. Okay, now let me have another example. Okay, so let's say our point is located at the fourth quadrant, let's say second quadrant. Okay, and this point, let me point it here, this is point B. Okay, if I'm going to draw a line from the point to the origin, okay, I can create a vector. Okay, and let's say this angle is equivalent to 65 degrees. Okay, now let's say this is also 3 units. Okay, this is positive x and that's positive y. Okay, so let's get the polar form. The polar form of this vector is 3 units with an angle of, now we have to determine what is the angle of this vector. Okay. It's not 65 degrees, okay, because when we measure angle, it should be from the positive x-axis. Okay, so therefore we can either make use of this one or make use of the other one, just taken from that one. Okay, but I will choose to take the orange line. Okay, so if this is 65 degrees and this measurement is 90 degrees, therefore 90 minus 65 gives us 25 degrees. Okay, so therefore this remaining, this one is 25 degrees. Okay, so to get the yellow angle, we're gonna be having 90 degrees plus 25 degrees. Okay, we have 115 degrees. So that is the polar form of our vector. Now for the rectangular form, okay, for the rectangular form, we need to get the triangle first. Let me draw the line for you. So So let me recreate the triangle. So that's it. Okay, and this is 65 degrees. Okay, and this is 3 units, right? We need to solve for side A and side B. Okay, so since side A is also the adjacent side, we're gonna be using cosine. Cosine 65 degrees is equivalent to adjacent side, that's A, over the hypotenuse side, which is 3. Therefore, A is equal to 3 cosine 65 degrees. So make sure that your calculator is in degree mode, not in radian mode. So A is equivalent to 1.2678. Okay, now for my side B, I prefer to use the Pythagorean theorem. Okay. 3 squared minus 1.2678. Okay, by the way, I prefer to use a continuous solution. So 9 minus answer squared, then apply square root. So that's 2.7189. Okay. So therefore, the rectangular form would be 1.2678 I hat and then 2.7189 j hat. But we need to identify who is positive and who is negative. Why? Because if you're going to take a look at our vector, it's in the second quadrant. Okay, and that second quadrant, if you're going to take a look at this triangle, okay, our side A is going to the west direction. Okay, if it's going to the west direction, therefore it's negative. Okay, and since our side B is going north, therefore it has a positive direction. Okay, so you need to be aware of that. Okay, now if your point is located at the third quadrant, therefore both the direction of your I hat and j hat are both negative. If it's at the fourth quadrant, okay, your I hat is positive and your j hat is negative. Okay. Anyway, positive and negative are just symbol of the direction. Okay. Now, next is scalar and vector units. Okay. So when we say scalar, it only has a magnitude and doesn't have a direction. Example, scalar and vector. Okay, so when we say distance, an example of distance would be 5 kilometers. Okay, distance of 5 kilometers only shows us a magnitude. It doesn't have any direction. It could be north, it could be going east, it could be going west or south or anywhere. Okay, therefore it's only a scalar quantity. Okay, now for it to become a vector quantity, we need to put a direction. Okay, so let's say you're going to travel 5 kilometers north. Okay, therefore you already have a direction. Okay, now from distance, now this becomes a displacement. Okay, displacement is a vector quantity. It has a direction, it has a magnitude and a direction. Now let me show you the difference. Okay, let's say this is my point of origin, point A. When I say distance of 5 kilometers, it could go anywhere from this point. It could go here, it could go there, it could be there, it could be here, anywhere. Okay, so it doesn't have a specific direction. That's distance. When we say displacement, okay, when we say 5, okay, So as I was saying, when we say scalar, it doesn't have a direction, and vector has a direction. Okay, these are perfect example for from point A. When we say a distance of 5 kilometers, it could go from any direction. But when we say 5 kilometers north, we are talking about a specific vector, which is this one. Okay. What else? Speed. Okay. When we say speed, it could be 5 kilometer per hour. Okay. To convert it from being a scalar quantity to a vector quantity, you have to put a direction, or you have to add a direction. Let's say that's 5 kilometers per hour at 30 degrees. Okay, so you have a direction already. Okay, and this becomes a velocity. Okay, so those are examples of scalar and vector quantity. Now let's go to the solution of the resultant vector. Okay. Resultant vector. Okay, let's say we have displacement 1. Okay, by the way, this is how you present a vector quantity. You need to put an arrow on top of it. Okay, let's say displacement 1 is equivalent to 2 kilometers east. Okay, displacement 2 is 1.5 kilometers north. Okay, displacement 3, let's say, is 1.5 kilometers northeast. Okay, there. So to get the resultant vector, first you have to illustrate it first. Okay, so let's say this is our point A. Okay, this is my point of origin, point A. From this point of origin, I'm going to travel 2 kilometers east. Okay, that's 2 kilometers. Okay, and let's name that as point B. After which I will travel 1.5 kilometers to north. Okay, from here, that's 1.5. Okay, looks like it. Okay, and let's name this as point C. By the way, I have to write the magnitude. Okay, this is 1.5 kilometers. Next, from point C, I'm going to travel 1.5 kilometer northeast. Okay, so where is northeast? Okay, it's in between north and east. So that's 45 degrees. That's 1.5 kilometers. Okay, now to get the resultant vector is like the shortcut from point A, from the initial point to the final destination. Okay, now from point A, I'm going to draw a line going to the final destination. Okay, and let me put an arrow, and that's our resultant vector. Okay, now we need to solve for the magnitude and the direction of that resultant vector. So how do we do it? We have different methods on how to solve for the resultant vector. First is the graphical method. For graphical method, of course, you need to be accurate when you draw your vectors. You could scale your drawing if you like, as long as you have they are accurately done. Okay, and then you just need to measure your resultant vector and the angle, so using a ruler and a protractor. Next is using parallelogram method. Now for parallelogram method, you're gonna be doing it 2 vectors at a time. So let me show you. Parallelogram method. Okay, so what you want to do is to get the first 2 vector. So this is your 2 kilometers vectors, and then your 1.5 kilometer vector, right? And then get the resultant vector of these 2. Okay, so let's name it as R1. Okay, so how are you going to do that? Okay, this is understood as an right triangle. Therefore, to solve for the magnitude of R1, you just simply have to get the summation of the square of the 2 other sides. So therefore, that's 2.5. Now, to get the direction, you can use tangent, inverse tangent. Opposite side is 1.5 kilometers over 2 kilometers. So kilometers will just be cancelled out. Okay, arctan of 1.5 over 2 gives us 36.8698 degrees. So that's your magnitude and direction for R1. Now, after that, okay, you're going to get the resultant vector of, so here is your R1. Let me just move it for you over here. There you have it. And then your D3, which is 1.5 kilometers north east. So let me draw northeast somewhere here. 1.5. That's it. Okay, and that's 1.5. Let me show you. This is R1. Okay, good. Now, we know this is angle theta, and this is 45 degrees. Okay, to solve for the final resultant vector, you just get the resultant of these 2. That's it. And that's your R total. Okay, and since this is not a right triangle, obviously, okay, so you can make use of cosine law, yeah, or sine law. So how do you what is the formula for cosine law? It's c squared is equal to a squared plus b squared minus 2ab cosine angle c. That's the formula for cosine law. Okay, since you already know the value of the 2 other sides, which are a and b, therefore and for angle c, this one, okay, you can actually solve it. Okay, if that is 36.86 and the remaining angle here, that's also 36.8698 plus 90 degrees plus 45 degrees. Therefore, your angle C is, okay, angle C is 107 71.8698. Okay, your side A, let's say, is 2.5 kilometers, side B is 1.5 kilometers. Therefore, you can solve for the value of side C, which is your magnitude of your resultant vector. So that's 2.5 squared plus 1.5 squared minus 2 times 2.5 times 1.5 cosine angle 171.8698 degrees. Okay, so we have 2.5 squared plus 1.5 squared is 2.5 times 1.5 cosine squared of that answer, we have 3.9905 kilometers for your magnitude. Okay, and for the direction, you need to figure it out. Okay, or you can use sine law. Okay, so sine law states that side A over sine angle A is equivalent to side B over sine angle B. Right. Okay, since we already have 171 for side C and angle C, so these are given, and our side A is 2.5, therefore this is 2.5, this is the angle B, I mean angle A. Okay, so we have 2.5 kilometers over sine A is equivalent to C, 3.9905 over sine of 171.8698. Okay, so therefore A is equal to arc sine of 2.5 kilometers multiplied by sine of 171.8698 degrees over 3.9905. Okay. Okay, so 2.5 sine divided by, so arc sine, so angle A is 5.0829 degrees. Okay, so that's angle A. Therefore, angle B is 180 degrees minus angle A minus angle C. Okay, so that's 180 minus the answer minus 171.8698. So 3.0472 degrees. That's angle B. This small one. Okay, and to get the direction of your total resultant vector, you just need to add 3.0472 to 36.8698. Okay, Therefore, the resultant vector is equivalent to 3.9905 at 36.8698. Okay, at an angle of 39.9170 degrees. Okay, that's our resultant vector. That is using parallelogram. Now we have the easiest way, which is the component method. Okay, method. Okay, for the component method, you have the x coordinate, y coordinate there. Okay, for D1, D2, D3, and then for the resultant. Right, for D1, okay, let me just copy this one. I'll copy it here. There. Okay, so D1 is 2 kilometers east. Okay, and the figure, where's the figure? Here. Copy. I'll paste here. Okay, so based from the figure, it doesn't have y coordinate. So that's 2 kilometers for x coordinate. That's positive because it's going east. Next, so this is 0. For D2, okay, it doesn't have x coordinate, so that's 0, but it has y coordinate, which is positive 1.5 because it's going north. Okay, now for D3, that's 1.5 kilometers northeast, that's 45 degrees. So that's, to solve for the x coordinate, this is the triangle, this is 45 degrees, that's 1.5. This is A, this is B. This is the x coordinate, this is y coordinate. Okay, to solve for x, that's cosine 45 is equivalent to x over 1.5. Therefore, x is equivalent to 1.5 cosine 45. Okay, and if that's cosine, therefore here we're going to be using sine. Okay, and you get the total. So 2 kilometers plus 1.5 cosine 45, we have 3.0606. Okay, next 1.5 plus 1.5 cos 45. So that's 2.5606. So they are both positive because as you see, the resultant vector is at the first quadrant. Okay, so we already have the x coordinate and the y coordinate. Rx is equal to 3.0606 I hat, Ry 2.5606 J hat. Okay, so you could write it as 3.0606 I hat plus 2.5606 J hat. That's already an answer. Now, if you want to put it in a rectangle or in a polar form, that's fine. Okay, so what will you do? You're gonna be using a Pythagorean theorem. 606 squared plus 2.5606 squared. Okay, and then gives us 3.9904 kilometers. For the direction, you're gonna be using tangent. Okay, 5606 over 3.0606. 2.5606 angle will be having 39.9169 degrees. So therefore, RT is equivalent to 3.9904 kilometers at 39.9169 degrees. Okay. So if we're going to compare our answer, okay, so here, look at them. Let me just copy so that you'll recognize the similarity. Here, see? Okay. And that's it for our refresher on angles and vectors.